Alright, welcome to Academic Digest class. Today we're going to be treating circular motion. And there are terms to note. We'll be treating equations of circular motion. Then we're going to be taking notes of certain terms and their formulas. Then the difference between centripetal and tangential acceleration. Then we'll talk about centrifugal acceleration. Alright. So with that said, let's use this. Right. So looking at the first thing here before us is what we call terms to note. So you need to note that circular motion, I like to define it as the motion of a body along an arc or curved distance. Full stop. So you can say along the arc of a circle, whichever way, but this is how I like to define mine. So sometimes you feel like circle is even circle, but it is well. Alright, terms to note. So if it's rotating, it's circle, it's going through a circular motion. So terms to note. The first thing you need to note is that this circular motion always have a linear part and it has an angular part to it. Now, you need to note that, for example, if this is a circle and a body is moving, this part is called the radius, the center, the distance from the center to the circumference. Then, if this is another part, what it makes here is called theta, and theta is what we call the displacement or change in position of an object going through a circular motion. So if I know this theta, what I will have here on the outside is what we call the arc distance S. Then what I have here is R. So you need to note that just the same way that in kinematics we have S, then in circular motion, that thing you call displacement is called theta. Then we know that first of all, that theta, according to our kinematics, that V is equals to S over T and S is equals to VT, if you remember from kinematics, if you remember. So but in circular motion, what you have S to be is that S is equals to, look at this thing I've drawn here, the product of this theta and this R. That is the change. Watch this movement, see. And notice that everything that happened here is as a result of this radius being radius 1, this one R2, moving from here to a place where this thing changes, changing S. So changing S, or you say S, tangential S. So or should I say angular displacement, changing distance. This is the one they call angular displacement. So another name for this is angular displacement. You need to know that. So we say that angular displacement, this one now is equals to, okay, so S, which is the arc distance, is equals to product of theta and radius. So you see it. So if I know this, we also need to remember, like if this is true, that means that angular displacement, which is theta, if you make it such a form, it simply means that angular displacement is equals to S, arc distance, all over R, all over this. Very important to note. Okay, then which means that if you check it very well, you need to also remember, so this is point 1, this is point 2, point 3. You know that V is equals to S over T. But in a circle, for circular motion, V is equals to S here is theta R, angular displacement times R. So it's going to be OR all over T. That is S over T. So notice that this thing you have here, that is theta over T, is equals to something in circular motion, which is angular velocity or angular speed. So we can say that V is equals to W. Then bring this R down. And this thing you're seeing here is what we call tangential or linear velocity formula. So linear velocity or tangential velocity formula is v equals to wr, and w is also equals to 2 pi. So which means that linear velocity is also the same thing as saying 2 pi r. Very important to note. Very important to note. So if I know this, we can now progress to the next part, which is, notice I'm using these principles of kinematics. It's more like, if you don't call this linear, you can call it or kinematics part, the kinematics knowledge, the kinematics aspects, because kinematics deals with motion. So we've talked about distance or displacement. We've talked about velocity here. Then we've also talked about velocity here. Very important to note. So the next thing you need to note is number 4, which is acceleration. So for acceleration, which is a, according to kinematics, we know that is v over t. But for a circle, in circular motion, we don't have velocity to be just v. What we have velocity in circular motion to be is that change in velocity is equals to v theta. V and change in theta. That is something like this. If I have this to be a circle moving, oh God, I've drawn nonsense. See, if I have this to be circle, and I have this to be r, have this to be r, have this part to be s, have this part to be theta. There is velocity here, there is velocity here. So what we normally do is bring this v, bring this u. So if you bring it side to side, the same way you have this, you have that, you have the first v, the second v, the first v. If you put this together, this is the change in v. So that is what you have. Then you have your theta. You have to be very thinking, very much thinking. Don't come and stand, be doubting. Look at it. There is movement around this, movement around this. So you carry the two and put it side to side. Vector knowledge. That is what I did. Carry this part, put it side to side. Then there will be a change in that. So if I get that, I will now have that this particular change will be a product of this and this, or this and this. So we now see that change in v is equals to theta u, or theta v, or v theta. So in circular motion, we don't talk about v, we talk about theta and velocity. So for that reason, where I now talk about, if I want to talk about acceleration here, I will now say that in circular motion, we have v theta. And remember that acceleration has to do with over time. Now notice that what you have here looks is like your w, because w, remember that w is equals to theta over t. W is equals to displacement, and you know that in circular motion, what we have as angular displacement, this is angular displacement w, and is equals to this is angular velocity, angular speed, and angular speed or angular velocity is equals to angular displacement over time. So notice what it means is that whenever you are comparing with kinematics, those ones that have to do with linear, when it's coming here, is always carrying theta with it. Why this one now is already in angular velocity, so no need to carry theta and v again, because it's already here. So it's just theta over t. So now if you do it, a is equals to vw. And then if you look at this very well, you can see that this means that your a can be talked about in two ways, because I know that vw, v first of all, from what we did here, v is equals to wr. So if I replace this v, it becomes wr times w. Remember that v is equals to, so that means that a is equals to w times w. A is equals to w square r. And also, if I look at this again, a equals to vw. If I look at this again, I'll very well see that w is equals to something, which is theta over t. But theta on its own, if you remember, theta is s over r. So I can say, if this is theta over t, then I have v. Then let's change the value of theta here, so that this becomes equals to v. Then putting the value of theta, we have s over r, then times let me do it here. V for V, then S over R for theta times 1 over T. If you put this together, you have Vs over RT. And if you look at this very well, this thing looks like something we know in kinematics. S over T, which is displacement. So A is equals to, let's say this is V over R, then everything here is V. So V times V, that is this thing now. So this is the same thing as saying V square over R. So that is how you get acceleration. So you need to know that this thing that we have here, yes, you need to know that this thing that we have here, which is where is it? W square R. This thing that you have here, W square R or VW. This one now, you can call this linear acceleration. Very important. You need to take your time and think about what I'm doing here without doubts. Let's take your time. So this is how to derive this. Then the next thing we need to talk about, going back to our question. So we are done with the terms. Next thing we need to talk about is equations of circular motion. All right. For equations of circular motion, if you remember from the concepts of, first of all, equation of motion, kinematics. Kinematics gave us V equals to U plus ET. Then it gave us S equals to UT plus half ET square for kinematics. That is for linear motion or translational motion or rectilinear motion or motion in one dimension. So then it also gives us V square equals to U square plus 2ES. Now for angular motion, what you just need to do is to remember. You need to remember first of all that in angular motion, what you call U is represented, that is velocity, is represented with this, which is angular velocity. And this one we have WO for initial angular velocity. Then what you call V is represented with W, which is final angular velocity. So if I know this, all I just need to do is to replace this in this equation. Where I see V, I put W equals to WO plus what you call A, acceleration. In angular motion is represented as alpha, something like this. So alpha T, that becomes equation 1, the first equation of circular motion. Circle is at an angle 360, so it's an angular motion. So if I say angular motion, I'm talking about circular motion. Then S, which is this your S, what you call S in kinematics, in circular motion, angular motion, we'll call it theta. So if they tell you find the angle made, it's talking about the same thing you call displacement here. So I will say theta is equals to, where I see U, I put WO plus half, where I see here, I put alpha T square. Then for this last one, this is equation 2. Then for this last one, which is equation 3. So for this one, I put, where I see V square, I see W square is equals to WO square, that is angular velocity square, plus half 2 alpha S, that is displacement. So this is equation 3. So these are the 3 equations of angular motion. That is just it. Now let's move to the next one. I said difference between centripetal acceleration and tangential acceleration. All right. Centripetal acceleration, just as the name indicates, when I see P, I will say it means center pointing. That is, this is the acceleration. This is the acceleration experienced by a body. Or acceleration that is found when a body is in circular motion, experienced by a body in circular motion. So any object you see that is rotating, for the fact that is rotating, there is acceleration that's, because this, for a body to rotate, there's a fixed point. So movement, or should I say the movement that keeps it to be uniform and try to be going towards the center if it can, even though it doesn't. But the slower it is, the more it tends towards the center, and that makes it stay at a place. But the faster it is, the more it goes away from the center. But at the center, it's still there. The centripetal acceleration is there. So whether slow or not, the acceleration that is found by a body that is going through a motion, circular motion, and pointing towards the center is called centripetal acceleration, while the one pointing away is called centrifugal acceleration. But we're not talking about centrifugal. So I normally say centrifugal means center fleeing, fuga, F for fleeing. But what we are doing now is tangential and centripetal. So for tangential acceleration, I normally tell my students, when a body is moving, let's say this body is moving. Watch, let's say this body is moving. As it's moving, the acceleration that is found in a body when that body is not in uniform motion. Notice this one, whether uniform or non-uniform, it is there. But when a body is slowing down, you will notice the components, the direction it is going. And when it's too fast, it becomes hard for you to notice how the direction is going. Like if your fan is really rotating, you won't know the direction is going. But if you notice this movement that I'm making here, I'm pointing towards the right. And if you check it, there is a component this way, and then there is the acceleration that is going this way. That is why we normally say that tangential acceleration is the force found in a body when it is slowing down or speeding up. So we normally give it by the radius from the center here. That is, as this thing is moving, it maintains the fixed path. The radius from the center and the acceleration. So we give it by the formula, which is AR. So tangential acceleration, or AT, is simply given by acceleration of the body and the radius. While centripetal acceleration that we've gotten is given by centripetal acceleration, AC, is given by V square over R. We derived it when we did all these things. This part where we did V square over R, this centripetal acceleration. And you know that if that is the case, just like what we did here, anytime they ask us force found in a circle, if force is equal to ME, it simply means that this is the same thing as saying mv square over r. Or you can say, since it's w square r, you can say mw square r as well. So now that I know tangential acceleration, which means that if a body is moving this way, notice, if it's going too fast, I might not notice it, but if it's slowing down, I'll notice that it's going towards the right. So I can see that the acceleration is going this way, and is moving this way, then the radius. So it doesn't matter. What matters is that the formula for tangential acceleration will always be AR. Okay, then the. Alright, so you need to know all these things. I normally give all these concepts before even solving. Everything is not calculation. So they now asked us what is centrifugal acceleration. So we can say that it is the acceleration that tends to move away, that tends away from the center. So I normally say center, and there's F here, fleeing. So as that body is moving out, in as much as, yes, it will still maintain its circular path and still point to the center, but there is this tendency as it's moving, it goes away, then comes back, it goes away, then comes back, because there's a fixed point. So I say that centrifugal acceleration is the motion of an object away from the center of the circle. So you can write it, pen and paper, you jot all these things down. All right, thank you. Subscribe to my channel. Next class we'll start solving problem.